Here are the steps to graphing cosecant and secant functions. You want to graph the sine or cosine graph using a dotted line. And then draw vertical asymptotes wherever the x-intercepts are. From the maximum minimum points, sketch away from the x-axis. You should end up with like little U shapes alternating up and down. So here's an example. Y equals -2 secant of 4x plus 2. My first step is to graph the reciprocal function. So that's going to be -2 cosine of 4x plus 2. Remember, you're going to sketch the cosine or sine graph accordingly. So if I were to graph this, I'll see that the period is 2 pi over b. So pi over 2 is my period. Therefore, my increment is my period divided by 4, or you can think of it as pi over 2 multiplied by 1/4. So pi over 8 is my increment. Notice that I have a vertical shift of up 2 units. Okay, so since I have my vertical shift of up 2, I'm going to go up 2 here, and that is going to be my new xy axis right here, since I don't have any phase shift left or right. Notice that your a value, right, it's negative, it's 2, so I'm going to go up 2, right, and down 2, so that I could have my amplitude of +2. Labeling my x-axis here, I'm going to go 1, 2, 3, 4 tick marks. I'm adding by pi over 8 each time, starting from 0. So pi over 8, 2 pi over 8, or pi over 4, right? If I add another pi over 8, I get 3 pi over 8, then 4 pi over 8, which is equivalent to pi over 2. Notice that my one full cycle is 4 pi over 8 or pi over 2 units long, which is exactly what we have. Okay, so now I'm going to graph a negative cosine function for my new xy axis here. So remember, if it's a negative cosine graph, I'm going to start at the minimum, then go to the x-intercept, go to maximum, x-intercept, and back down to the minimum. So let's go ahead and connect these dots, but we're going to use a dotted line because that's not actually my final graph. Okay, this is just an aid to help us. Now remember, anywhere you have an x-intercept, right, you are going to have a vertical asymptote because 1 over 0 is going to give you undefined. And we're using our new xy axis to help us with the graphing. Then wherever you see the maximum and minimum points, you're going to start there, that's part of your graph, and then go away from the x-axis. So you're going to go away from it. Okay, right here you could stop there, or if you want to draw on the other side, that's fine too. Again, you're going away from the middle here, from the x-axis, or fake or new x-axis. Okay, again, you can draw on the other side if you'd like for symmetry. There's our final graph. Okay, so let's go ahead and graph y equals cosecant of 2x minus pi. So remember, first step is to graph a sine or cosine function. So it's y equals sine of 2x minus pi that I'm just going to graph using a dotted line. My period is 2 pi over b, so it's pi, and then my increment is the period divided by 4, so it's pi over 4. Notice that I have like a plus or a minus sign inside of the sine function, so therefore I'm going to have a phase shift. So the easiest way is to set that equal to 0 to get x equals positive pi over 2, therefore my phase shift is going to be right pi over 2. Remember, phase shift is just a fancy word for horizontal shift when you're dealing with sine and cosine functions or trig functions. The other way, just as a side note, that you could have rewritten this, like, or found the phase shift, is by, or like right here, is by factoring out that b value. So if I factor out the b, I would end up with x minus, well, 2 times what would give you pi, right? It would be pi over 2. So do you see how if it's written this way, you can right away see that you're going right pi over 2. But then you had to do that extra work of factoring the b value out. Okay, let's go ahead and graph this. So usually if I have a phase shift, I'm just going to wait till I put my y-axis. So here's my right pi over 2, and then I'm going 1, 2, 3, 4 tick marks to the right of it. So I am adding pi over 4 each time. So pi over 2, if I get a common denominator, that's really 2 pi over 4. And if I add pi over 4, I get 3 pi over 4. If I add pi over 4, I get 4 pi over 4, or pi, then 5 pi over 4, and 6 pi over 4, or 3 pi over 2. My y-axis would be where 0 is, so it's just to the left somewhere over here. And I am going to mark my a values of 1 and -1. So here is my new xy axis that I'm going to use to help me graph. So I am graphing a positive sine graph, therefore I have my 3 x-intercepts. And then I go up to a maximum since it's positive, and then down to a minimum. Again, I'm going to connect the dots using a dotted line because this is not part of my final answer. And the next step is anywhere you see x-intercepts, right, you would put a vertical asymptote. Vertical asymptote. And the last step is wherever you see the maximum and minimums points, right? You include that as part of your graph, but you go away from the x-axis. So you go along the 2 vertical asymptotes away from the x-axis. And this is my final answer.